We have Naveen with us today, and he's going to be teaching us SHM or simple harmonic motion. So Naveen, tell us, what are we going to be studying in this chapter?
Yeah. Since this is a new chapter for you guys and you have not studied anything related to this in your school level, so we'll first see how this motion is physically, and then we'll go on to model it with a mathematical equation.
Okay.
And then we'll understand the parameters included in that mathematical equation physically as well as mathematically. And then since this is a motion, it has both kinetic and potential energies, so we'll learn those energies and how they vary with time. So this is a brief gist of what we are going to study in this SHM chapter.
Okay. And now tell me, when we are approaching this chapter, solving its problems and studying it, what are strategies that one should employ, and what are things that one should be careful about so as to not make mistakes?
Yeah. The most important question from this chapter would be something related to time period of a system.
Okay.
So to find out this, we'll be learning two methods. One is force method and the other is energy method.
Okay.
So depending on the problem, you have to choose one of the methods out of two. This would be like you would learn this from practice, one from practice, and the other is from observing the problem.
Okay.
Like if you have more forces, obviously you won't choose force method, you'll go to energy method, and if you have less forces, so you choose force method. Depending on the problem, you have to go for the method.
Okay, so
and then the other kind of problems would be very simple problems, but you have to be careful in solving them. Something like related to the equation of SHM. They will give you the boundary conditions, you just have to substitute them into the general equation and then find out the amplitude or phase constant or something like that.
Okay, so one should be careful when solving these problems.
And one more thing would be, you might get the answer in terms of sign, but the option would be in terms of cost, so be careful to have both answers at your hand, one in terms of sign and the other in terms of cost.
And also ensure that you're looking at radians and not at degrees as such, right? Because radians are the ones that you can mathematically use in the equations directly.
Yeah.
Okay. Now tell me this, what's interesting about simple harmonic motion? Like, what interests you or boggles your mind when you look at it?
See, you must have seen vibrations throughout your life in one of the systems. For example, when you sit in a car, you have a lot of vibrations, you don't know where it is coming from. So there's a lot of research going on this. It comes from engine block, it comes from the shaft, everywhere. So the most basic of this is SHM. You use the fundamentals of SHM to model this, and then you reduce this.
Oh, so even the bumpy rides that we have can be made better using applications of SHM as such.
Exactly.
Oh, sounds interesting. I think SHM does have a lot of other value that adds to it. To add on to it, another thing that's specific about the SHM chapter is how they will mix and match problems across different streams, right? We're going to have...
one more important thing, this is problems in SHM are mainly focused on mixing of two chapters. Like you won't get a direct question from SHM, it is coupled with electricity or magnetism or even fluid mechanics. So if you are thorough with the concepts, the basic concepts, you can easily solve the problems in SHM.
Okay. So with this, let's dive into the problems. I think we're going to deal with a variety of questions and it should solve all the issues that they will have about it, right?
Yeah.
Okay, so let's jump right in.